Abigail needs to say go or I'm not starting.
Go.
Go. All right. Hi, everybody. Welcome to another episode of Continuous Discussions, the online forum where we talk about Agile, DevOps, and continuous delivery. I'm Sam Fell.
And I'm Anders Wallgren, and today's topic is DevOps for mainframes. Yeah, it's a real thing. In the 60s and 70s, mainframes ruled the data center. They're big beasts for sure, but they're not necessarily dinosaurs. They're still heavily in use today. Powering some of the largest sites and operations in the world, mainframes get the work done. And they're here to stay for both legacy and for new applications and especially large scale type things. So how can you modernize mainframe-based applications? Can DevOps ways of working coexist with mainframes? What are some of the challenges and common patterns you're likely to see on this sort of mainframe journey? Those are the topics that we're going to cover today. And as always, we have a great set of panelists to help us out.
Fantastic. All right. Well, first on the list, Robert Stroud. Welcome back to the program.
Hello, everyone. Good to be here.
We also have Glenn Everitt from CompuWare. Glenn, introduce yourself.
Hi, I'm Glenn Everitt, and I work in the product management group at CompuWare, working on a new test product for mainframe DevOps of all things. We're working on automating the process of testing inside of your tool chain inside of mainframes.
Wonderful. It's great to have you here. And
Thanks.
last but not least, Santosh, welcome.
Hi. Hi, I'm Santosh Vaswani, working as a technical manager at eInfochips, and I'm working for the DevOps implementation from assessment to with the different continuous deployment and continuous integration testing, and also the automation process.
Great.
Fantastic. All right. And so those folks are on the panel. If you are not on the panel but you'd like to be heard, go ahead and use the hashtag C9D9 on Twitter, and we'll try and get your comments onto the program. But let's go ahead and get started with the meat of the conversation. And the first question is, should you DevOps your mainframe activities? Should you try and practice DevOps around a mainframe, and what are the benefits of doing that? Let's go ahead and start. Glenn, your face is up when I come off of the thing, so why don't we start with you?
Sure. That's one of the premises that we've been working at for the last couple of years. When we first started talking to people about DevOps on the mainframe, we got a lot of weird looks, like, what's that all about? And when we started telling people that we actually have done that here at CompuWare, there was a lot of surprised looks. And now we have a lot of people who are asking, how do you really do that? How do you really start that process? Part of it's tooling. The culture part of it is a big issue. And then you've got processes. A lot of these mainframe shops have these enormously huge and complicated processes. And some of that needs a little bit of deconstructing so that you can go faster. But DevOps on the mainframe makes a lot of sense. And one of the key things that we've seen is, a lot of people complain about the cost of a mainframe, but what I keep finding out is it's not so much the cost of the mainframe as it is the speed of the mainframe. There's a lot of frustration with getting stuff actually implemented and in production on the mainframe. So that I think is one of the main reasons you want to do DevOps on the mainframe, is to get that speed in your processes and get stuff to production faster.
So you mentioned culture. Do you think there's a bigger difference, culture in sort of distributed teams and culture in sort of mainframe teams?
Yeah, I think there is. And one of the things is you've got a lot of people nearing the retirement age in the mainframe world. And so, a lot of these guys are not interested in changing at this particular moment in their career. Whereas you've got, at the same time, you're because a lot of people are retiring, you're getting this cultural or this generational shift happening at the same time. You see new people coming into the environment that weren't there before. And the kind of the interesting thing about that is that when we go in there, the first people we are generally talking to in the DevOps is usually a distributed team, and they're trying to pull the mainframe people into that process. And when they do that, there's also young people on that team. And a lot of times they kind of shame those old guys into doing stuff I think they wouldn't normally want to do, in terms of, oh, we'll start automating this, we'll start doing this stuff. So it's really great when you've got this mainframe team that actually is starting that shift. It really helps you move forward in that DevOps approach, because you've got new people that are excited and wanting to use these new tools. So give me my green screen and my ISPW and stay off my yard kind of thing. So it's nice, a younger generation in there.
Get off my
crazy
lawn.
Kids.
I love that. Yeah, that's funny. All right, very good. Rob, should you DevOps the mainframe?
Oh,
You should DevOps everything, according to Rob Stroud, I'm sure. But what are your thoughts?
I think you should DevOps everything, as you said, Sam. Absolutely. You know, it's really interesting. The DevOps the philosophy was a little bit late to the mainframe world, and we really didn't think about it initially. You know, DevOps traditionally is about going fast and agility, and the mainframe is about stability and consistency, and certainly in the past. And we go through these long, rigorous control processes before we rolled anything out in the mainframe. We were waiting for our window at 2 a.m. on Monday morning each week. And if you didn't get your change in, you missed out for the next 6 months.
Yeah.
So the reality is that we've actually, you know, the mainframe is a pivotal part of, you know, 92 of the top 100 banks, almost 10 of the 10, you know, 10 of the 10 top insurance companies, you know, healthcare providers. The mainframe is everywhere. And the reality of it is to become an equal citizen, the mainframe absolutely has a part to play. And that's one of the things we've seen, is that we've seen DevOps processes extend to the mainframe, allowing development teams to get quite agile and deliver velocity. And they're actually learning that by doing smaller, consistent changes, they're doing it better. So with lots of words, the answer is yes.
Fantastic. All right. And Santosh, what are your thoughts on should you DevOps your mainframe?
Yes, definitely we should go for the DevOps for the mainframe. The reason is still there are the 80% of the products still using the mainframe on the backend side for processing. Mainframe was developed with the waterfall model, while nowadays web application, mobile application, and all the applications are running with the agile methodology. So we have to take that mainframe also as a agile methodology. Otherwise, what happens, we are lag behind into the time to the market. And also, if we look into the automation side, there are very limited tool sets available for the mainframe, like COBOL unit testing and all that things. So we have to come up with the tools and more tool chains using which we can completely implement the DevOps process for the whole mainframe as well as non-frame applications.
Yeah, that whole feedback loop and making sure that that work can be automated. It sounds like, Glenn, that's something you guys are working on, which sounds pretty
Absolutely.
Yeah.
It is, you know, and that's one of the key things as we talk to a lot of our mainframe customers. The thing that really surprised me is how much manual testing is being done. You know, these are your credit cards, these are your, you know, transactions at retail stores. These are things that kind of matter. So, and a lot of this stuff is just manually unit tested. That's not to say it's all manually tested. A lot of the functional tests has been automated, but for the most part, a lot of the core business rules are tested manually, and that's kind of scary. So, you know, bugs being introduced is quite easy, particularly in mainframe shops, because the builds tended to be much more infrequent than they were on the distributed side. So because these builds were infrequent, if you had a bug in there, it tended to stay there. So that's why I think automated unit testing on the mainframe makes a huge amount of sense. And it's surprising to me that it really wasn't available. There's not really a lot of tools, as Santosh was mentioning, that allow you to do that. So that's one of the reasons why we kind of jumped in there, because we realized the things that we wanted to automate, we wanted to be able to automate your build, we wanted to automate your deploy, and we wanted to be able to automate your test, so that you get those 3 key steps all automated so that they just happen and you're not waiting on someone to actually do that next manual step.
And make sure that it's boring. And as you mentioned earlier, the complexity of all the stuff that's behind that mainframe, right? The stuff that's running in there. You could change something and think that you're fine, and then some process runs that was dependent on that. It's a monthly thing or a yearly thing, and all of a sudden it's just clobbered whatever it is. Yeah, clobbered whatever it is you've done. And I have a story about that. When I worked at State Farm, I actually used to code mainframe, IBM IMS hierarchical database, and we were moving to from printing to an actual printer, to printing to a spooler, and having it called savers. I don't know if you've heard of that, but it's like a PDF-atizing that stuff. And I brought down all of the State Farm regions when they did their claims processing.
You were very popular that day, I bet.
At 2 o'clock in the morning, and it's
my!
Any DevOps at all, no sort of DevOps stuff, and so that was pretty brutal. That is about as much as I can offer for this conversation. Anders, DevOps and mainframes.
Yeah, I mean, you know, I think they're pretty interesting. I think almost by definition, anything you're running on a mainframe is going to be mission critical.
Mm-hmm.
Because we're not serving avatars for people's faces and stuff from the mainframe. We're doing highly concurrent transaction processing, Visa, MasterCard, Amex, those kinds of things, banks, and it's legacy code. We throw that term around a lot, and I always like to say that legacy code is code I didn't write. But in this case, in some cases, it truly is legacy code produced decades ago, and maintained mainly through the heroism of some people who, as we know, are nearing retirement age. So it's a little bit of a unique place culturally and technically. That said, this is just software, right? And the core DNA of every piece of software is very much more like the core DNA of every other piece of software out there, whether it runs on a phone or a mainframe or a drone or whatever. And so the same principles apply. The techniques and the tactics may be a little bit different. I remember a couple of years ago, maybe 3 years ago, at the DevOps Enterprise Forum up in Portland, Scott Prue from CSG talked a lot about the kinds of things that they're doing with their mainframe work. In particular, just the steps that they took to just start doing some automated testing. And they were pretty smart about it. They started very small. They wrote one test. And then a week later, they wrote another test. And then eventually, they had 5, 10, 15 tests. And they were able to sort of put these tests in high-value places where the code was changing still or problematic or so on. And so they were kind of doing, boundary kind of testing and API layer testing, those kinds of things. And even that small step from going, from 0 automated testing to a dozen or so was a huge benefit for them. It would catch problems. And then since then now, they're kind of in the mode of if we touch it, we test it. So if we go in and we fix a bug, we create a regression test and those kinds of things. So it's doable. I think mainframe is probably, there are certainly interesting things just because it's mainframe. That makes things a little bit more interesting tooling-wise, file system-wise, those kinds of things. But at the same time, mostly what we're dealing with, and I don't mean this that pejoratively, mostly what we're dealing with is decades-old legacy code. Right. And so we treat that the same way we would any other decade-old legacy code.
Well, there's a lot of decade-old Java code now, too.
Exactly. Yeah, exactly.
And, I like the Michael Feathers definition of legacy code. It's basically code that you don't have test cases for. So if you look at it from that perspective, there's a whole lot of legacy code in the world, not just mainframe legacy code. But turning your code to not be legacy code, that means creating a bunch of tests for it.
Yeah. And understanding it.
Wants to go around and create 100 code coverage for this code. That isn't necessarily the right thing to do. Nobody's going to stop for 2 years while you do that. So it's really about how do we get the biggest return on the smallest investment in terms of finding the right places to put that test code, because I think that's really where the most value is initially.
Absolutely. So we've talked about a few of these, but let's dive in a little bit deeper about some of these challenges that we'd run into when you're trying to do DevOps for mainframe, or you're trying to more modernize the way that you interact with and deploy these systems. And let's start with Santosh. What are your thoughts on this?
Sure. So basically, one of the challenge of the DevOps with the mainframe is there is a complex and fragmented development pipelines. Some of the mobile development is going on, some of the mainframe development, some of the web development. Now, to set the complete workflow automated by combining all these things, it is not just as a pure play IT application. It is some far more better than that. Second challenge is environment as a code. So basically, that virtualization of the mainframe system, that is one of the challenging part that we also need to cover while doing the DevOps implementation for this mainframe. The third line is that there are the different product pipelines are running. So some of the things are on the mainframe and some of the things are migrated to some different newer environment. And the fourth challenge which I see from the mainframe is there is a legacy mainframe systems, and we need to provide the solution to support that things with the cloud infrastructure as well. And the fifth challenge which I can say is the release cadence, like one release is like mainframe application has the lesser number of releases compared if to mobile application or web application. So here sometimes what we do not focus for the DevOps implementation for the mainframes, and that gives the like late in the market to us for the automating the whole process.
Just the sort of the fear of interacting with it means that people don't interact with it means that it's sort of a vicious cycle there, right? The less you can update it, the less likely you are to try and update it. Interesting. All right, we seem to have lost Rob. Glenn, I'm going to go to you and hope that Rob comes back in time for this question.
Well, I agree with Santosh. You know, a lot of every application on the mainframe is really an enterprise. Almost invariably touches multiple platforms, as he was saying. And when you do that, trying to, like, if you've got a distributed set of systems that are all trying to do DevOps, and when you get to the mainframe, you're not doing DevOps, and that means you're not being able to deploy when everything else needs you to deploy, that's a big problem. And so, you know, what we kind of focus on when we go in, you know, I've already talked about testing, but deployment is kind of the next step. You got to have your ducks in a row with your deployment of your application so that you can keep pace. Now, even if you're not making any changes to anything, you know, just getting all the pieces assembled and knowing where all the things are that you need to deploy is a huge first step, and it's an important step. You know, right now what we see is a lot of companies have a fragmented set of scripts that they use, and pieces or parts are spread across multiple groups and people, and so a deployment turns out a lot of phone calls between people, and that's where failures occur. You know, kind of my definition of it's not automated, it's not going to happen consistently, on time, or correctly. You know, there's always going to be some sort of problem. So being able to have all of those pieces well defined so you know where they're going, that's a big deal. So, you know, one of those steps is not just being able to test it once it's deployed, but you got to get it deployed in the first place.
Yep, absolutely. The deployment piece of that is super important, and making sure, as Santosh was mentioning, is that you've got these multiple different types of applications that are also dependent on that mainframe. And so you have all these different pipelines that are going to be moving forward. How do you coordinate all of those different pipelines with all of those different releases, even when there may not be anything major being changed somewhere? You have to still do that integration testing somewhere and make sure that those things are going to work together. Do the automated testing that you have on the mainframe side, but then also testing on the things that are going to interact with the mainframe, because I'm assuming, and this is a question more than a statement, that there are probably a lot more people that interact with components that interact with the mainframe rather than people who interact with the mainframe directly, right? So it's a system of systems, and it just the integration of those and the testing of those starts to become very complicated. Anders. Oh, go ahead, Glenn. Go ahead.
Oh, I was just going to say, you know, we look at these orchestration tools as if you've got enough integration with your orchestration tool, you can drive both or multiple platforms. We see a lot of distributed systems being driven by orchestration tools, and we've got our mainframe systems also being driven by these automation tools through an orchestration tool, and that really makes a huge difference in moving this stuff along faster.
Yep. Anders, what are your thoughts on that?
Yeah, I mean, you know, as with anything related to this kind of stuff, getting the human out of the loop is always a good idea. We're you know, I say this all the time, but I'll say it again. You know, we suck as humans at typing the right command into the right terminal window at the right time, especially when we're tired, under stress. We'd rather be home with the family. You know, all of those kinds of things, and that's certainly no different with mainframes than it is with anything else. You know, I think you know, there are other challenges, and I think Glenn may have mentioned this earlier, but, you know, we don't necessarily have a line of people at the door wanting to learn these things either.
Right.
You know, get familiar with how mainframes work, and, you know, it's not necessarily the case either. I'm guessing here now, I'm not 100% sure, but the amount of innovation that's happening inside of the mainframe community is probably not that great either. That's a judgment call I'm making. I don't have specific knowledge of that, but
we look at,
correct me then.
We have some other, you know, I think we're being very innovative at CompuWare with some of the stuff that we're doing, particularly with unit tests. But overall, I would look at the mainframe vendor, I don't see a lot of progress in some areas that I would have expected to see. And we're talking to some of our customers recently, and they're saying, yeah, we know this is old, but we don't have a replacement for it in anything. So that's one of the dilemmas is, when you start wanting to do this integration with these other tools, that takes some effort from a vendor to actually provide those integration points for those tools.
Yeah.
And so, to your point, if there's no innovating vendor actually putting those things in, it's really hard to tie it together into these other new systems.
Yeah, and then depending on what flavor of mainframe you're interacting with, you may or may not have some of the more familiar tooling chains that we're familiar with,
Right.
Shells and scripting languages and those kinds of things. And you may be the only, and this is the case in one customer that we're working with, the only funnel we have to deal with the mainframe is to FTP job control files, JCL files, to and from. And that's really the only, that's the only knob we have to turn. When do those things get picked up and run? When it feels like it.
Yeah.
When are they finished? I don't know. So there's this kind of batchiness also to some of the implementations, where the idea of sort of real-time status updates and real-time information and those things weren't necessarily built in from the beginning. So the systems that people have built around this are, as with any legacy code, if it's not the right architecture for what you want to do for DevOps, you've got to invest some time into figuring out what to do about that. So
I think it's partly also looking for some of the tooling that really simplifies things. If you have a modernized tool set for your developers to be able to develop code, you're going to get faster, better code. And some of those challenges you're talking about, being able to get stuff moved to the mainframe, see what the output from that job was, see whether, the faster you make that development, you're going to get results. And then that's what the key thing was on the development on distributed systems, is that cycle time between the code debug, see what happened, and try it again. The faster that cycle is, the more results you get.
Right. Rob, welcome back. We're talking about challenges, DevOps on the mainframe. What are some of the challenges that you've heard people talk about or that you're keenly interested in telling us about?
First, I need a mainframe so I don't drop off. That'll be good. The challenges are kind of there in that if you look at from a code perspective, often you see that code is being built with business logic and all the various aspects, communications, everything all integrated into one in terms of old code. Yeah. They're bad coding practices and practices we gave up 20 years ago. But if you think about it, the main stem of mainframe code is it gets more and more complicated over time, and that's where the term spaghetti coding obviously came from initially. But the reality is that if you think about it, those challenges can be overcome. Like people liking their old green screens for coding and things like that, right? The reality is we've got people who've built up a career of data, a career of information to actually, build those practices up. So we've got to change that. And then there's the other false challenges, things like, oh, you can't touch the mainframe, it'll break. You can't touch it, it's complicated. Yeah. You can't do this, you can't do that. These fallacies are built up from the 70s when the hardware itself was fallible and did break, and you did need to get it resolved. That's not true anymore. We're now in, we're now well into the future, so that we've really got to look at these things. That hardware's reliable now, software's reliable, we've got good tools, and the challenge is we are stuck with a bunch of myths from the past. Seriously.
Yeah, absolutely. So at State Farm, one of the projects that I worked on was to try and recreate the logic of the claim system in a distributed Java system using a Corba orb, if people remember that. This was a long
my goodness, I bet that was a fun project.
Yeah, it was cool. It was N tier. The reason we had figured all that stuff
out. We could have kept the mainframe.
We ended up keeping the mainframe because we could not reproduce the decades of business logic and all of the, if it's hail or if it's this or if it's that or if it's this. And we get the project stalled because we didn't understand business logic that was in the code. And so how do you iterate on something that you are legitimately afraid to touch because you're going to impact someone's claim, some business logic that, as far as you know, is working correctly. And that, I see that as a huge challenge.
Yeah, and I think it's fair, and just sort of echoing what Robert said, I mean, some of these problems are not about mainframe. They're about this code. Right. This code is really old. We weren't as good at these practices 20, 30 years ago as we are today. You know, yes, we still write spaghetti code today, no doubt, but as an industry, I'd say we're a lot better than we were. And that, I think that accounts for a lot of the challenges too. You know, I mean, it's tricky when you're dealing with very fragile systems that you're afraid to touch.
Yeah.
Well, one of the other things is like refactoring, and I think that's kind of a cultural thing. You know, in the mainframe world, I wish I could, you know, take a baseball bat to the next person who says, if it's not broke, don't fix it, because you really have to look at, you know, how long do you think this code base is going to be maintainable? You can't afford to rewrite it, so you better fix what you've got. You know, go back and look at the Y2K fiasco. You know, oh, the sky is falling in Y2K, and that was fixing just a few things. Think if you were really going to migrate an entire set of mainframe applications, the amount of work that would be compared to the little bit of work we had to do with Y2K and the drama that was associated with that.
Yeah, yeah, exactly.
But, you know, the other myth is, and I come across this a lot, is that, you know, there's no cool factor to the mainframe. It's not relevant, it's old. You know, that's another myth that's out there right now.
Yeah. I mean, there's so many cool things that mainframes provide. I mean, I don't own a computer. Well, I don't own a mainframe, but I don't own a computer where I can replace CPUs without taking the system down or push more memory in or out. I mean, I know I could probably buy a, you know, Sun E10K or whatever. Well, they don't exist anymore, but, you know, you used to be able to pull CPUs on those things. But I mean, mainframes were built for, here's a huge monolithic thing that can't go down. It has to stay up 24/7, 365. Now we do that with distributed computing and by having 1,000 computers, and we don't care if 10 of them go down, right? This was in the age of building one piece of iron that had to keep running. And there were lots of interesting design decisions and compromises and innovations made just to be able to do that kind of stuff. And honestly, if you want massive transaction rates on one piece of hardware, I mean, mainframes are it. You know, you've got to build up a pretty good stack in AWS to be able to touch what, you know, the kind of transaction rates that some mainframes can go through.
Well, you have to build up more than a pretty good stack in AWS to simulate mainframe transaction throughput and response time. Yeah. You know, the data is fairly clear. I mean, you know, if you've got a really, really large application, you've got no choice but a mainframe. It's the only way to really run it. Still, you know, will that be the case in 20 years? With nano computing or something else? Probably not. But the reality is right now, you know, we're in that transition period, and yet I still get a lot of calls that say, we just want to kill the mainframe. And I say, why? We did a business case that says it's more cost effective. And the boss said, oh, the board don't want to hear mainframe. They want to hear cloud, right? That's all they want to hear.
Tell them it's an on-premise cloud.
Yeah, yeah, absolutely.
That's what it is.
Well, yeah, and mainframes have virtualization and zoning and, you know, slices, and I don't know what all the different, you know, terminologies are, but I mean, they're pretty damn sophisticated, right? I mean, there's a lot of stuff that it took us decades to get as far along in the kind of the x86.
Docker, been there, done that.
Yeah, exactly.
Been there, done that. I mean, yeah, it's there's a lot of really interesting stuff in there.
It's like, I don't know if it was Kernighan or Rich who said it, but, you know, those, you know, those who don't learn Unix are bound to recreate it poorly.
Doomed to repeat it. That's funny.
Hey, you can run Linux on the mainframe. It's there.
Yeah, absolutely.
Yeah,
absolutely. Yeah. Take advantage of all that hardware.
Monitoring is also playing the vital role, because in the DevOps, the monitoring that mainframe are performing the very critical operations. So there should not be any downtime for that mainframe system. So even when we work like with eInfochips working with complete product, then we have to see from the implementation of the mainframe monitoring solution, as well as how we can make them automation and how we can make that release cycle faster. So that all the challenges came together, which are working differently from the application side, because embedded side is also involved over here. So we have to see on that side as well, mainframe, application, all three combinations.
Absolutely. And so just to sort of highlight the challenges, like Glenn talked about culture earlier on, we talk about the complexity. Is the challenge of having multiple different teams, is there a collaboration aspect of mainframe, and how do these teams work together, and how do you pull that code base forward? Is that also a challenge, or is that not as much because it's a centralized team? That's a question. I don't know the answer.
It can be well, I mean, first off, you've got a different culture in the mainframe side versus the distributed side. Again, the distributed side, those folks, you know, they're used to having tooling that allows them to speed through and deploy stuff frequently. The mainframe side, you may have people who check out code at the beginning of the 6-month period, and they check it in at the end of the 6-month period, and then they give it a good once over to make sure it's working. And you know, the difference between those two sets of people can be quite great. But again, that's just behavior, you know, and behavior can be changed. Not easy to change behavior, but it's completely changeable. And so, you know, I think one of the challenges again is, you know, there's the people aspect and getting them to change their behavior so that they're not afraid to make a change. And again, that fear, you know, and we talk about fear at CompuWare a lot. Like there's the fear of COBOL, the fear of the mainframe, there's fear of changing code, and it all comes back to, how do I know I've broken something? And it goes, have I got a way to test it? So people, if you can eliminate the fear, they're much more willing to change. So if you eliminate that fear of, you know, COBOL is no harder than any other language, probably simpler than PHP, in fact. Right down to it, you know, bits are bits, and you know, code is code. If you've got a couple of if then else's, I mean, that's your programming language. And so I'm always amazed when people get all hung up on the fact that it's COBOL. COBOL is not the problem. It's the fact that you have 100,000 lines or 500, like a customer I'm working with now, they've got a 500,000 line program. How do you manage and maintain a 500,000 line program? That is difficult. So you need tools that are going to actually help you do that, to kind of slice and dice and understand how all those hundreds of thousands of lines are working together. That's not a trivial feat. That's the hard part. COBOL and the language, simple.
Right.
I couldn't agree more.
Monolith.
Yeah, I mean, you know, we're sort of blaming our tools a lot if we the mainframe is the problem or COBOL is the problem. No, it's what we did with them. That's really. Yep. I'm sure given the appropriate conditions, we could have produced beautiful code in COBOL and mainframes, highly maintainable, you know. Yeah. But that wasn't how we did it back then.
I think for some reason we thought bigger was better back in the 70s, and then we finally realized that bigger wasn't better. Being able to test these pieces independently of one another made a huge difference in the simplification of being able to actually verify that something is working.
So that's a fantastic point. Yeah.
We work with some aerospace companies, and you know, oftentimes they're working on cost plus contracts.
Yeah.
So more hours to them equals more profit. So they don't share code between projects. They clone repositories, and they never go back and merge or anything. And these are 5-10 million line code repositories. I would imagine there's sort of similar things happening back in the day. Right. In terms of, well, you know, we're going to reuse the stuff.
Well, yeah, we encounter that quite often. Some of our tools allow you to go through and analyze your code base, and you'll find, you know, there's a large percentage of dead code. There's a huge amount of duplicated code. So what they found is, back in the day, it was easier to copy a set of lines of code rather than refactor and add a couple parameters so you could reuse that code. So that's why these code bases just balloon to these enormous sizes. And that's when we start looking at, when you want to modernize, it makes a lot of sense to modernize on platform. You eliminate a lot of the risk of performance and some of these other things. You can kind of target the pieces you want to actually update. And you know, you eliminate a lot of risk by going to another platform. If you go to another platform, someone said, I wish I could remember who told me this. When you go to another platform, Glenn, your maturity level drops down to 0 again. You're basically starting over with all those performance testing and all those bugs. You got to fix them all over again, because to Sam's point, you don't necessarily know what all those requirements are that you were lost in that 500,000 lines of code somewhere. They were in there, but trying to figure out where they are is not so easy anymore.
Yeah, trying to divine intent by spelunking code is always an interesting prospect.
Yeah.
Yeah, exactly. Excellent. All right. It sort of seems like people talk about the decomposing the monolith, and it seems like the mainframe is the ultimate monolith. And how do you refactor? Glenn, you mentioned that. Yeah. And Santosh, you mentioned that. How do you refactor that code and pull out the business logic and make it more modularized and segmented out? And maybe that's hard to do. I know that sometimes it's easier to start with a clean piece of paper, but in a lot of instances, maybe it's not. So let's talk about some patterns that you've seen work for your clients, your customers, your partners, for DevOps on the mainframe. And let's start. Who have I not started with? I have not started with Rob, I don't believe.
Yeah, so, well, I'm on this time, so you can start with me. So, you know, the reality of it is that if you look at some patterns with mainframe, the first thing we need clearly, and the first pattern we see is starting with a modern editor, a modern IDE. We've seen this happen across the game. There's a lot of, let's just say, legacy or historical love of green screens and green screen patterns, but the reality is we're going to attract net new developers to mainframe, which is what we've got to do, by the way, to preserve its heritage. We really need to give them a modern development environment, and I think that's one of the first things we see. And the reason, and you'll probably think it's a bit strange for me to say that in this call, but the first thing you do when you do that is you can then, in a modern development environment, apply modern techniques. Coding in smaller groups of code, automatic testing, automatic branching, automatic merging to branch, nice modern source repositories, all those cool things we do in DevOps, by the way. And the reality of it is that in doing that, we get the same advantages. We were scared to do DevOps on distributed 8 years ago, right? We were really worried about it. You can't do more than one change a month. No way. Never. You've got to have a full back out. Everybody's got to come in at 2 a.m. and do this. Now we do changes in real time. The same is true happening on mainframes, where we look at our code, we look at our environment, we do automated testing, we pull it through. We then look to how we roll out and deploy our code. So we're doing automatic deployments as well. But the secret sauce is we're applying the same practices. And this is the secret sauce of being successful. And this is what we see when organizations do this, when they leverage DevOps in the mainframe and they start to look at their code and they start to look at the way they transition it. We clearly see a change in practice, and that change in practice reflects in better code with greater quality, the things we talk about all the time. But additionally, we learn things about the code. We look for redundant code. We realize there's modules that aren't used anymore. We can pull them out, and there are tools to help you identify that as well. But as you do that, you can refine, refactor that code over time. There's no need to simply replace it. If you've got 30 million lines of code, and don't think that's unusual, it actually happens. Going and transitioning that in one foul swoop is never going to work.
Right.
So you've actually got to take a constructive approach. And this is what we're starting to see organizations do now as they balance the migration off the platform to looking at how we modernize the code. You know, and I'm sure others have an opinion, but you know, it's applying common sense, I think, and good DevOps practices. And we wrote a document on that at Forrester last year, and on you know, the mainframe needs DevOps. And it's really interesting from an analyst perspective. I get inquiries on this every day almost. So it's definitely a lot of organizations talking about it.
But the things that you're saying makes perfect sense, right? Take an agile approach to how are you going to evolve this big beast, right? Don't do it in one fell swoop. Incrementally make changes.
Yeah, I mean, you need to put some tactics and strategies behind that, of course, right? But the reality of it is it's not impossible. And if you look at, you know, and I know our buddy from CompuWare is right here. He'll love to tell us about CompuWare's own migration. But even all the major developers of mainframe technology have now transitioned to DevOps and are now delivering their own code, leveraging DevOps techniques on a regular, consistent basis. And, you know, Glenn can probably talk about the value props they've seen at CompuWare on that. But the reality of it is, if you do it and do it effectively, there's great value to be had.
There's an interesting story in there, I'm sure, about how often the tools that CompuWare is providing to its customers is updating. And I'd love to hear, are people embracing that and taking the updates as quickly as now you can probably pump them out? That's an interesting data point as well.
Yeah, that is an interesting data point. Well, one of the things, back to the modern IDE comment that Rob made earlier, one of the things that's interesting about that is there's an element of discovery with an IDE that on the mainframe, the normal tools on the mainframe, you just have to know where everything is. Whereas with an IDE, you can discover stuff. And that's, again, that's important for this generational shift. And one of the things we've noticed here is there's like the millennial underground. These guys, we don't want to ask the old guy. We're going to figure this out on our own. So they use our IDE tools to actually figure this stuff out on their own, so they don't have to ask the old guy, which I think is quite cool. You know, I mean, I think that speaks to the, you know, the type of people that tend to go into this field. But one of the other things that when we were going through this transition ourselves, we have, I think, 24 different products or SKUs that we actually build. And so when we went through and did an inventory, I think we had, let's see, 24 different build processes for those 24 different products. So when we started adopting this DevOps approach, we said, maybe it would be smart if we tried to consolidate those 24 different build processes into just one or two different processes. And everyone said, of course, no, this can't possibly be done. And this is what we hear from every customer. So if you're looking for a pattern, this is one of them. My build process is so unique. This is what you'll hear. My build process is so unique that it couldn't possibly ever be moved and modernized in any shape or form. So this is the very first thing. And we proved that wrong because we went down and shrank the number of build processes we have. I think we're down to about 4, because we've got 4 different languages inside of our product. So we're down to about 4 very similar build processes. And one of the things that meant is we eliminated 2/3 of the time it takes to build our product, because now we've got a consolidated build process. So you're going to we save so much time. We used to have all these people embedded in a particular project, and their job was to do nothing but make sure the thing got built. And, you know, we would build it in pieces parts. And so it's not like we were doing a continuous build process. Mm-hmm. So we would discover things later in the process than you would ever want to have happen. So this consolidation and standardization of your build process is a key first step in that DevOps journey. You know, and again, this is kind of goes to the whole build, deploy, and test process. So you got to be able to build it consistently before you can deploy it consistently. You got to be able to deploy it consistently before you can test it consistently. So going down that path makes a huge, it frees up resources to help you do that next step. And that's one of the things that's beautiful about what we've done. We're able to do so much more now because we're doing less of the same crap across 24 different products than we used to.
And that's a big hurdle that I think everybody has to get across, because, and it's not mainframe specific, which is we are the duck-billed platypus. What works for you won't possibly work for us. We're different. Right? Yep. And newsflash, nobody is
not so much.
You're not a special snowflake. Sorry.
Yeah, sorry. Your environments maybe and all of that kind of stuff, but now it's just code. I have the same kind of attitude about people who say, "Oh, we can't possibly automate that kind of testing." You know, BS. Yeah. You can automate everything. You don't even have to build a robot for most of it. So, you know.
Yeah, no, you really don't. A lot of the tools are there. You have to kind of dig a little bit or push them, pull them a little bit. But, you know, and again, none of this stuff is new. Essentially, a lot of the stuff that we're automating are manual processes that we used to do. Even if, you know, if you look at the process and, you know, generally they're automatable. You know, and the other thing that I think a lot of people miss is some of the steps in their process were because steps were done manually and people make more mistakes than machines make. So there would be an extra 2 or 3 levels of check because, well, Susie always messed this up, so I'm going to add another level of check. Or I don't trust that group over there because they always, one time back 30 years ago, they sent me something that was bad. So I'm never going to let that happen again. So I'm going to add 2 levels of manual check in here. And, you know, those things, when you start really looking at them and why they were there, you can almost always point to some crazy disaster that happened in the oftentimes very distant past that really isn't necessarily applicable if you've got an automated system in place to now manage that particular piece of the project.
That's repeatable, consistent.
Right.
Yeah, absolutely. Interesting. Santosh, What are your thoughts on patterns for developing on the mainframe and doing DevOps in the mainframe?
Okay, so basically, if we say that, okay, we are transforming from mainframe to take it to the DevOps, then sometimes it is not like easily adoptable. So what we are doing currently, first we do the DevOps assessment. The DevOps assessment will give us the status where we are standing currently. Are we on the level 1, level 2, level 3, level 4, or level 5? So that levels are like initial, manage, define, measure, or it is optimized. So after doing the assessment, we can find out which are the reusable components we can use on each of the level. Like how can I make the build more better with the unit testing, with the code analysis of this mainframe application, and how we can deploy this into the mainframe system. So I have to find out the deployment tools also. So basically that levels are different for the build, for the deployment, for the monitoring, for the test, and for the this release also. So all that I can do the analysis that, okay, I'm standing on L1. How can I move to the L2? Then we can utilize our reusable components and we can enhance that mainframes to take into the better like optimize or measure level. So you can show the ROI also. Like if we invest that much of tools or that much of processes, then definitely we will, what type of return we will get from this DevOps implementation. So DevOps assessment will definitely help us to show the picture where we are standing. How can I move forward?
And Santosh, when you say the return on investment, what does that mean? What are you saying? Is that productivity return on investment? Is that competitiveness of your mainframe application? Help me understand what that means to you.
Okay, so basically, for example, there is no DevOps for the mainframe application. So now the release time is 3 weeks period of time.
So market
Now,
competitiveness.
after implementing the DevOps, I have reduced directly from the 3 weeks to 1 week. So directly there is a saving of the 2 weeks period of time, whatever manpower we are investing on that. So that way we can articulate the easily the ROI things, that what exactly return on investment we will get after doing this DevOps implementation.
Got it. So faster time to market, being able to capitalize on opportunity, being more aligned with the market need. Okay, that's fantastic. All right, Anders, any thoughts on this? Any patterns that you've seen that have been good, or things to avoid? Actually, those are also very good to hear.
Yeah, no, there's a couple of things that I've heard people talk about over the years. One of which I already mentioned, which was Scott Prue talking about how they just started small, get a few tests going, kind of get the machine cranking a little bit, and once you have something that exists, now you can edit it. Now you
Build
can
on top of it.
Build on top of it. So that's kind of important. As with everything, don't boil the ocean. Don't try to eat the whole whale. All of those kinds of things. Start small. The other thing I've heard a lot about is kind of the idea of providing a little bit of isolation between the core mainframe implementation and its clients, using service facades or other sort of services or APIs in between, to kind of give you a little bit of isolation where maybe you didn't have it before, so that you can start to rearrange things under the covers in the mainframe a little bit. None of these things are unique to mainframe applications. I mean, most of this is just abstraction and kind of good practices. They work just as well in this arena as they do elsewhere, not surprisingly.
Yeah. So one of the things I'd like to ask folks, the Puppet State of DevOps report that was just released in conjunction with DORA, one of the factors that they said was a great predictor of success with continuous delivery was the ability to create a loosely coupled architecture with loosely coupled teams. And so given sort of the conversation that we've had here and sort of the patterns that you wanted to move to for doing DevOps on a mainframe, how realistic is it for people to have a loosely coupled mainframe architecture? Are those two things counter-indicatory? I'm saying that wrong, but you know what I mean. Glenn, you're laughing. What are your thoughts?
A lot of code on the mainframe is highly coupled. You've got a couple things going on there. There's a certain, a lot of these programs essentially work on the same set of data. So the if you're going to change the data, the programs have to change. If the programs change, a lot of times the data has to change. So the coupling is tighter than you would like. That being said, you can still pull these applications apart and work on different pieces of them. You have to be careful about how you do it. You may have to build some facades. You may have to build some data stubs so that you can get enough of the thing done before you roll it into the major part of the product to get that done. To your point about putting facades between the mainframe and other distributed platforms, we see our customers doing that all the time. That's one of the things. In fact, what they'll do a lot of times, because they're worried about time lead on the mainframe side, is a lot of time they'll implement something on the mainframe side, have it actually available and deployed, and then they'll be sitting there waiting for the distributed team to be able to connect up to it. So they'll go ahead and create these applications or these APIs ahead of time and just have them there available.
So the mainframe teams that you're working with are ahead of the distributed teams in some cases.
In some cases, yeah.
Bravo. Yeah, that's wonderful.
No, loosely coupled. I totally agree. We see mainframe teams having leveraged an API integration strategy some time ago with API tools. So applications have become very dependent on mainframes and integration between apps. If they were early adopters of API strategies, they've been doing this for ages. And a good strategy we often see implemented is exactly that, where the mainframe team will implement the base functionality maybe once a month, just because of the cadence of regularity, and then the distributed teams will then leverage that over the course of the next couple of weeks, and can use canary releases, blue, green, whatever they want, dark releases to turn the features on and off or turn the capabilities on and off. That's becoming very common now.
One of the other patterns, we talked about patterns just a minute ago. One of the other patterns I see with a lot of our customers, they've created a kind of a group of SMEs around DevOps. And, I've seen some companies where they created a separate team that's responsible for deployment and testing and all that stuff. And that usually seems like that creates yet another silo, which is bad. But this center of excellence kind of team that goes from group to group and helps them out and on that DevOps journey, that seems to be a model that works well. So they're familiar with the tools, they're familiar with, again, the patterns that they see over and over again related to, this, we can't possibly come up with a standardized build process. These guys roll their eyes, they say, no, here's how you do it. And they kind of walk them through those steps. So having that centralized center of excellence kind of team that can go from group to group and help them kind of drink the Kool-Aid, get the religion, whatever you want to call it, buy into the whole DevOps thing, really, I think is a huge benefit for these companies. They get a lot of bang for the buck out of doing that.
Very good. Any patterns that people want to bring up that are anti-patterns, things that you should not do, like just huge stub your toe type fails? Because I think that would actually be interesting to hear.
Yeah, don't drink the Kool-Aid because it's actually poison.
Okay, Jim.
There's that.
Jim Jones, here we go. Okay.
Sorry.
That's okay. No one has anything that happens that's bad. No one's ever seen anything that's a bad pattern. Okay, well, that's wonderful.
Well, I think the bad pattern is the denial that we are different from everyone else. Yeah. And I think the other assumption that people make is that people can't change. One of the things that surprised me is when we started going down this path of DevOps, I thought, oh my God, there's some of these guys that are never going to make this change. They're 2 years away from retirement or whatever. He's never going to change. And I've been amazed and surprised because they've completely engaged in the process and jumped on and really made the thing work. And you really need the involvement. If you alienate the very people who are going to help you make that transition, you're in trouble. That's definitely an anti-pattern. Don't go in there and tell them everything you've done is rubbish, because it's not. Like I said, a lot of the reasons why they have these crazy processes is to, coping mechanisms from past sets of crazy, either political issues or, lack of trust between groups. You start knocking down those silos and getting these people talking to each other. I can't tell you how many times our release engineering group has just really helped out our application groups get stuff built. And, and that's because there's give and take between the two teams. And these guys are a lot more flexible with the gray hair than you might expect them to be. So don't count them out.
Yeah, at the end of the day, they're engineers. And if you present them with a plan that looks and smells like it can be more successful than what they've been doing, then they're going to try it. They're going to test it out. So that's great. Robert, you look like you have something that you want to add.
Yeah, my simple anti-pattern is make sure you do value stream mapping. It's you know, I see too many organizations just assume the mainframe app is cool and good and wonderful from the get-go. You know, we couldn't be wrong. You got to do value stream mapping. There's a lot of fat. In fact, what I see from talking to customers is I have actually seen a lot of opportunities to reduce your code size, pull out functions that are no longer used, pull out stub code. So many opportunities to make that code run more effectively and efficiently and make it easier to understand. So make sure you allow a little bit of time to retire technical debt.
Right.
That's big. And I think that in the mainframe world, anyone who disagrees with me, please raise your hand. But I think there's a lot of technical debt.
There is. You know, we see customers with 20% dead code in their applications, and you know, and then you're talking about, well, it costs me X amount to maintain a 100,000 line program. Well, if you took out the 20% of your code that's not doing anything, that might, you know, save you some money along the way here.
Yeah, straight out value saving doing that.
Yeah.
Straight out save money.
Yeah.
The most important thing that an engineer can do, software engineer, is delete code.
Yeah.
You are the most productive, I think.
Yeah.
That's
Anders
a multiplier.
Anders and I were working on slides for a webinar that we have coming up with Jez Humble on the 27th of this month, where we're talking about loosely coupled architectures and how do you get there. We're not talking about mainframe specifically, but I took Anders' slides and he said, hey, do your magic on them. And my magic was that I reduced it from 30 slides down to 16 slides. And that unlocks the magic, honestly. Getting rid of all of the dumb stuff that he said and just focusing on all
That was stuff you thought was good, right?
No, simple is hard. It's, you know,
It is.
It's easy to throw up a bajillion lines of code for something, but to, you know, solve it simply and maintainably and those kinds of things. There's a bit of craft to what we do. I don't want to take it too far, but there's definitely an aspect of that.
All right. Well, this has been a fantastic conversation. Speaking about an art form, thank you to the panelists for bringing all your knowledge on this topic to bear for us on this episode. I've certainly learned quite a bit. Mainframes are still definitely relevant. We see them all over the place. You interact with them every day. Whenever you do something, even on your iPhone, chances are there's a mainframe behind it. Providing you with the information or the transaction that you need. So it's very critical that you're able to do these types of activities, the DevOps types of activities there. So thank you all for joining. Thank you, Puma, for sponsoring. And what does it say on the back?
Go Swans, Sydney Swans.
Oh, very nice. Yeah, I don't follow cricket or whatever. I don't know what that
Australian rules football, buddy. It should be next C9D9 is about Australian rules football.
All right, that sounds good. All right, Santosh, Glenn, Robert, thank you guys for joining us. We'll see you next time on another episode.
Thanks so much.
Thanks for having us.